partner product. Oh, I thought that was preview mode. I don't know what that means. All right. So go down through here and at least say, what does this mean to an application? Not everything's going to mean something to an application. Elastic Cloud. Man, that sounds like an AWS thing, doesn't it? It's got the word elastic in it. Elastic anything points to AWS. So I'm not sure what this means. Elastic Cloud. What is that under? That's under analytics. So some of these lesser known things are not going to be on the exam. Networking. Some of these have sub network parts to them, which you used to get to by clicking this. Now you have to click into it. Again, I hate this UI. Distributed cloud, serverless. Again, I'm just trying to find what I'm looking for here in this now changed up. They've added a whole bunch of these new database options here. Again, not sure where that plays. Again, it says here, this is a partner product. I think what this means is they've made a deal that Mongo, Atlas, Mongo, is, if you click on this, let me see if I can do this in another tab while I'm just answering this generic question. I think it's going to open up the marketplace. Yeah, opens up the marketplace so you can download this MongoDB. Now, MongoDB is a managed service database in AWS. It's probably in the second tier of popular databases. In the platform, you got MySQL, Microsoft SQL Server, and then you got the NoSQL. There's been probably, roughly in the late 90s, there was this big shuffle around trying to figure out what an object-oriented database would look like. A whole bunch of interesting history there, all having to do with Moore's Law, the whole Moore's Law thing. Bunch of, don't have time to go into it now, but if you go back and I don't study, that sounds like too big, review the history of technology and put it into, examine it under the lens of my Moore's Law curve. Now that you understand my Moore's Law curve, you'll see a lot of things that were there because of the limitations of infrastructure that we no longer have to do because the bigger, better, faster, stronger part of Moore's Law makes that not needed anymore. Here's a quick example. Right now, today in the 2000s, let's say the 2010s, 2020s, say 20, whatever. HTTPS is just what you do. It's not even, oh, you're not HTTPS. Like, how dare you? That didn't always be the case. When the World Wide Web first got created back there in the 90s, late 80s, early 90s, there was HTTP. That's what you did. And it wasn't because we didn't care about security. It was the impact of doing certificate validation, the cost of creating a validation certificate, and then the performance impact on the browser of validating a certificate over a 9600 bit per second modem was too slow. So the performance impact of HTTPS made it impractical for anything except the extreme cases where security was important. Moore's Law curve changed all that: bigger, better, faster, stronger, faster networks, faster processes, blah, 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 blah. Now the impact of the same certificates, that's the important thing to remember here. HTTP certificates didn't change. So it wasn't some new technology of certificates that made this now reasonable. It was the infrastructure changes that now makes the creation of certificates cheaper and faster, and the implementation of validating certificates negligible from a performance point of view. You don't see it when you go to a site that's an HTTPS site. You don't go, oh, this is kind of slow. It just happens. It's now within the noise of other network performance issues. The latency of your ISP is potentially greater than the latency of the certificate. So you're just like, okay, no big deal. That's an example of bigger, better, faster, stronger. So now when you start looking at everything under the light of that Moore's law curve, you see things about databases, for instance, if we're talking about databases. Back in the 90s, when we had objects, the big brouhaha was to create objects in your applications because that's conceptually better. But then how do you store an object? Well, you couldn't because you had relational databases. Relational databases weren't object databases, they were relational databases. So you had these goofy things called object relation mappings that took your objects and then mapped them to tables. This goofy thing. And the reason was the implementation of objects in a database was too inefficient. It wasn't that we didn't know what to do, it was the cost, the impact cost of doing what was conceptually obvious just functionally didn't work. So now you go into the 2000s and the 2010s, networks become faster, storage becomes cheaper, all of those Moore's law things. Now somebody goes, just store the object, just do that. And so what happened now is that from a legacy point of view, from a database legacy point of view, relational databases had a head start. They got their claws into application developer psyche because they were there first. Now they weren't really there first. If you go back to the early 80s, you had Clipper databases and other kind of databases, but for the most part, in the bulk of what we would call good application development, you had MySQL and Microsoft SQL Server. And so relational database got a foothold. And then because of Moore's law, we have object-oriented databases, NoSQL databases, and they were always initially clunky because performance was just there came a point, I'd have to look up the time, where I first started trying to use an object-oriented database because it made sense, but it just wasn't good enough yet. Performance just wasn't there yet. And so I had to do one of those mental rationalizations. Like, this is conceptually better. As an early adopter, I'm going to do this because it's the right thing to do. And I would try to implement an object-oriented database, and it just, at some point I go, I give up. I can't make this work well enough. Then I'd convert everything back to a relational database and it worked fine. Today we don't have to do that because of Moore's law. I mean, it's so interesting, I find. Hopefully you do too. Okay, so now we have these object-oriented databases like Mongo and Cassandra and other things that are out there that are now mainstream that Google wants to not support, but they don't want to bring them in as first class A managed services. So I think what's happening is that they are creating these alliances with these third-party companies, which used to be the marketplace, which used to be called Cloud Launcher, I think. The marketplace, which is we're kind of open source. We want you to play in our sandbox. We're not going to give you real estate on our dashboard, but we'll give you this marketplace place. So that, from an application point of view, always trying to tie it back to this class, is the integration of your applications to other services is easier in Google Cloud if you're one of these most favored partner products than it is in AWS. And certainly in Azure. Azure is like its own little community of stuff. All right, so that's what I think this thing is down here. You're not going to be asked a test question about MongoDBs in that case. Maybe there might be a day when MongoDB comes up to the Alloy DB status and gets, primary heading status on the list here. Anyway, that's just that. Observation, app CDIC. So we got the container registry artifact. This doesn't go away. This is now gone as well, but it's still there. And then we go down to integration services, tools, deployment manager. There's what I was looking for. Under tools, miscellaneous tools, you got deployment manager. So deployment manager, know the term. This is also deprecated, even though it's still here. This is like trying to get rid of a peanut butter and jelly sandwich. It sticks to your hand. You can't get rid of it. You can't, these things don't go away. So Deployment Manager was the Google version of Terraform. And so the Deployment Manager, just because we don't have a slide on this, I'm going to wave my hands a lot, is Deployment Manager / Terraform is called Infrastructure as Code, IAC, Infrastructure as Code. The idea is that you would create a description using a particular format of what you wanted your infrastructure to look like. Here I have a VPC, it has subnets, it has these regions, it has IP addresses, here's a compute engine, it has these compute engine instances, here's a Kubernetes cluster, here's a cloud storage, here's a firewall rule, blah, 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 blah. So in this description file, in this description file, you would identify all of the pieces of your infrastructure. And then you would have a agent, a deployment manager tool that you would say, make this file real. And so the deployment manager / Terraform would look through all the things and goes, okay, I'm going to build this, I'm going to build this, I'm going to build this. So since everything in Google Cloud is an API call, all that the deployment manager / Terraform utility did was look at your English description and say, oh, that's this gcloud command. Here's the parameters in Englishese, kind of pidgin English. I'll turn them into the appropriate syntax in gcloud. So it's like creating a gcloud script in gcloudese without having to know all the particular syntax of gcloud. Okay, but you need to know the particular syntax of Terraform. So is it that much better? So here's the difference: is Terraform was created for it only was useful in Google Cloud. It was a Google Cloud specific product, kind of like the source code repository. And then nobody used it because the real life is that our customers have on-prem data centers, they have AWS data centers, they have all kinds of stuff. And Terraform was multi-platformed. So back in the day, before Deployment Manager became the Google Cloud de facto standard, I would ask people, I would say, here's Deployment Manager. I said, how many people use Deployment Manager? Nobody would say anything. I said, what is your infrastructure as code tool? And everybody would say Terraform. Now, Terraform and Deployment Manager are not the only two out there. There are Pilot and a bunch of other ones that people have come up with. It's just literally let me take this organized outline with a particular syntax and then have a utility to parse that and build the tool. So both in Deployment Manager, but specifically in Terraform, since that's the service that's being used now, you describe this thing, and then in Terraform, kind of like Docker, you install Terraform, the Terraform utility, and then you terraform things. So like in the Docker world, you install Docker, then you Docker build and you Docker run. In Terraform, you terraform things. So there's a Terraform init, which builds out the little tool. Then there's Terraform plan, and Terraform plan takes this thing and looks to see if it makes sense. So it's a preprocessor and it looks through all this stuff. It says, no, you've got references to things that don't exist. You've got these things that don't work. And in Terraform, it's kind of cool that it is a sequence of builds, and it knows when you describe this that this has to be built after this is finished. Because if you just supplied a bunch of gcloud commands right in a row, if there was some infrastructure requirement, like you can't deploy a compute engine in Belgium until you have a VPC in Belgium. So there's in Terraform some syntax that allow you to build in dependencies. So it's complicated, it's intricate. Very powerful, very intricate. Now, the power of that is you can take this Terraform script, I call it Terraform script, and then you can save it in a repository. So you have all of when anybody says, save it in a repository, you instantly pop up a little bubble in your mind that says version control, rollbacks, separate paths, testing, blah, blah, blah. There's a whole bunch of features that there's attributes that go along with repository that you just pop in your head. So anytime if I say, oh, the Terraform, you can save it in a repository, that is the shorthanded way of saying version control, rollbacks, roll forwards, testing. deployment, blah, blah. There's a whole bunch of features that just connotates. So the cool part is if you marry that idea to Google Cloud, you can define the infrastructure of a solution. Now let's get this back into the application space. You can define the infrastructure of the solution your application is going to run in. As we saw yesterday in the question, Terraform doesn't deal anything with the application itself. It's the infrastructure the application runs in. So then you can take that Terraform definition, you can templatize it. So there's some parameters. It's kind of like a template stored procedure. And then you could execute that in different Google projects. So if you had a project called loyalty card, let's say, we'll use a restaurant. We have a project called restaurant testing. I can deploy the restaurant infrastructure in the testing project and then run the application over there. I can take the same Terraform description and run it in the production project. And now I know that the application is going to live in the same infrastructure because I used the same build definition for that. So that's a useful tool to eliminate things that could be different between your testing and your production environment that causes the application to break when you move it to production. That was always an issue. Okay, so that is that. The other thing that you can do with Terraform, again, has nothing to do with the application, is that if you modify your Terraform script and you reapply it, so there's a init, plan, and apply. If you apply it, which says actually do it, it's only going to change the infrastructure to be what's different in the new plan. It doesn't remove the old infrastructure and build a new one. It just, that's the same, that's the same, oh, this is new, let me change that. So it's a useful tool. Again, the application doesn't care. The application has nothing to do with Terraform at all. So yes, Hector, a CloudFormation is the AWS equivalent, I believe is correct there. All right. So that's the issue with Terraform, Kenneth. Fine. Useful for application developers, like I said, to build testing environments very, very carefully, and you can tweak those and do some stuff there. It's also useful, in the, let me actually try to make this work for an application developer. When you have an application, so you remember yesterday there was that exam question about the migrating a monolithic program to Google Cloud and you're changing the VM. Well, it's conceptually easier if you're trying to tweak the infrastructure for optimal purposes to use Terraform and go through your little script there and go, oh, let me change this, apply it, and then, oh, that didn't work. Roll it back to the previous one, make a little tweak, roll it. So it's easier than going into the console and trying to remember what things you changed and what things you put back. That's just harder to do. It's easier if you have this documented, cohesive plan. Okay, there's that. That's that. Anyway, having to do with deployment manager, that I think that was the question I wanted to answer for Kenneth. Okay, so now it is almost 12. We got an hour left. I want to spend a few minutes before we get into questions today talking about the actual exam mechanics. You don't have any slides for this, but you'll just have to wing it here. So I'm going back to my tip and technique slide. And if you don't need to take screenshots of what I'm about to tell you. I'll give you some demos and you can, when you go to take the exam, these will it'll be obvious. But I want to warn you ahead of time of the mechanics of taking the exam, the mechanics of signing up for the exam and the mechanics for tasting the exam. The mechanics is just for your own benefit, how you actually sign up for the exam. I mean, it just is what it is. It's not hard. The mechanics of the exam, the tips I'm going to tell you are useful so that you don't waste seconds trying to figure out what the screen means. So remember, my whole emphasis of the class from the exam point of view is to give you insights how to save seconds. Out of the 120 minutes that you're going to have, you need to save seconds. Doesn't sound like a lot, but it adds up. Okay, so that means I have to go back to the beginning of this little thing. So yeah, I stole this from a previous class. All right, so let me, first off, before I get into that, let me go to the exam sign-up mechanism. Okay, which I have one more question. Why in cloud build YAML syntax GCI, Google Cloud run, blah, blah. So, container registry. Well, it's the same reason that, it's the same reason they still talk about Stackdriver instead of operations. There's just legacy holdover names that it would be difficult, let's call it challenging, not quite impossible, nothing's impossible, but just more work than necessary to go back through the underlying infrastructure of all of the Google Cloud systems and change the name of an acronym. So it's that you got to remember, this is again not having anything to do with the test, but remember that everything we see in Google Cloud is an illusion. All of the services we see don't really exist. All of the services are implemented as a software virtual service. So the underlying infrastructure has its own names for things. And every once in a while, those names pop up. So like, for instance, the older version of Kubernetes used to be called Borg. Every once in a while, you might see a reference to Borg. Now, is somebody internally still calling Kubernetes Borg? Probably. There is here's another example. Again, this is way off topic, but you asked the question. You remember I mentioned when we were talking about cloud storage buckets and compute engine disks. I said those are all, there's no such thing as a balanced disk. You remember I talked about that with persistent disks in compute engine. The implementation of compute engine disks is a database. When you create a 10 gig drive, that is not mapping to some 10 gig drive on some rack behind me. It's actually creating a database entry in a database system called Colossus. And the Colossus database is the disks, is the implementation of disks. Now, of course, the data in the database is actually stored on disks, but it's not your disk that it's stored on. It's an illusion. So that's why Google can create something called a balanced disk, because it's the implementation of a performance-oriented configuration that, as long as the underlying database can support that, Moore's Law, bigger, better, faster, stronger, they can implement a new feature. So it must be challenging for the Google engineering people to constantly map in their head what the public sees and what's actually happening under the surface. So every once in a while, these things populate out. So the implementation of the artifact registry container, the artifact registry container repository is probably still the container registry, because there is no thing in the underlying infrastructure called artifact registry. There's no thing, I think. I don't know this. I'm just assuming. The implementation of the artifact registry is a combination of underlying services that get combined up to become the artifact registry. So the container repository in the artifact registry is probably still the container repository service underlying that. So they still call it GCR. I think. I'm just guessing, but yeah, that's one of life's mysteries. I went here for a reason. What was I talking about before I was talking about that? Oh, the registration process. Okay, so if you go to, let's see if I can do this officially, Google Google, cloud, professional cloud developer exam. And you go to, normally I would get this directly, but you go here to register for the exam, and you go to this web assessor page. And again, you don't have to copy this down, it's just what you do. And then you log in. So I've done this many times. So I have an account. You have to create an account in the web assessor space. You get this thing and you sign up for an exam, register for an exam. You pick your exam. Like they have in different languages. So let's just pick one that I don't have here. Data engineer. I don't have the data engineering exam. So you pick that and you can choose to take it remotely proctored, which means it's at your house or your office, or on site, which is their on site, not your on site. So you choose this, whichever you want, $200. At some point when you choose this, you pick whatever it is you want. You just go through this little process. It's just like a store. And you select this and you pick a day and you pick a time. You go down here. Again, I'm not covering this in detail because it's pretty straightforward. And you acknowledge this and you select that and you get to this checkout form. So it's just like a store. And here's where you put your voucher code that you're going to get in the mail after this class or some point in the future. You put in your voucher code and that gives you this $200 credit, just like a store. And voila, now you're signed up. So if you choose to do it on their site or you choose to do it at your site remotely, you just go through the particular pages. Then you're going to get a confirmation email, blah, 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 blah. You can reset the testing time, et cetera, et cetera. There's, you can reset the time within 48 hours of that, or a bunch of constraints here. Just read the details of that. That's not important to the exam. Then when you go to take the exam, there's a little decision tree depending on whether you're doing it on site, on your site, or on their site. If it's on their site, you walk into the office there. This is the way I always do it. You show them some ID, then they look up your name. So it's not a Google testing center. It's a generic